Hello, pre-algebra students. This lesson is called Scale Drawings. Drawings or models, if you think of those like an architect would make, or like a map would be a scale drawing, they are made to scale. The scale is determined by the ratio of the given length on the drawing or model, and that's compared to its corresponding length of the actual object. So in other words, a map. On a map, if it says 1 inch represents 8 miles, then a map is drawn to scale. Of course, if you open an atlas and you look at the state of Tennessee, that's not the real size of the state of Tennessee. It's a scale drawing of the state of Tennessee. So for example 1, our map, every 1 inch truly represents 8 miles. So two towns are 3.25 inches apart on the map. What is the actual distance between the two towns? Alright, so here is our scale. 1 inch represents 8 miles. So if on the map we have 3.25 inches, the question is, how many miles is this? Now this is not a unit rate conversion. We're not trying to cancel out miles. It's not a multiplication problem. It is a cross product. We're setting up a proportion. So we're going to take the time to say 1 inch times x miles, 1 times x is x, and then 8 times 3.25. And we're looking for miles. So when I do the math, I find out that x is 26 miles. Alright, on our next example, Sheila is designing a patio that will be 16 feet long and 14 feet wide. If she's drawing it on graph paper, where each block on the graph paper represents 4 feet, how many blocks wide and long will the drawing be? Okay, so we are comparing blocks to feet. We're talking about blocks on graph paper. Picture your graph paper. We're saying each block here represents 4 feet on her graph paper. So if we're comparing one block represents 4 feet. That's the ratio of her scale drawing. So to find the how wide and how long, so width here was 14 feet. So let's, in red, we'll do the width. So one block is 4 feet, and the real patio should be 14 feet wide. So how many blocks will that be? That's what we're looking for. How many blocks? So when we cross multiply, 14 times 1 is 14, and 4 times x is 4x. So when you divide by 4, it turns out to be a fraction, and x is 3.5. 3.5 what? 3.5 blocks to draw her scale of her width. This was the width, 3.5 blocks. Alright, the other half of the question says, well, what about the length? So let's do that in blue. We're searching for the length. Alright, our ratio is still 1 to 4 blocks to feet. I'm going to abbreviate blocks. Alright, so it told us here that the length, how long it is, was 16 feet long. So how many blocks is that? That's what we need to find out. So we cross multiply. 16 times 1 is 16. 4 times x is 4x. Divide both sides by 4, and the length should be 4 blocks. Alright, moving right along. I am so looking forward to going to Washington. I hope I get to go this year. I didn't get to last year. In this next problem, we have a scale drawing of a Washington monument. And it says here, Lucy is drawing a model of the Washington Monument, which has an actual height of 555.5 feet. Her model is 19.25 inches. So if we're going to compare the model to the actual size, The comparison is going to be 19.25 inches to 555.5 feet. That's the scale. What other information is needed to find the side length of the square base? All right, so this is her drawing, and if we were looking for the base, what else does she need? Does she need to know the height of the top of the tower? No, we already know its height. Does she need to know the length of the actual base? Oh, well, if we're trying to make a scale drawing for the base, they have not given us any information about the base. I think that sounds like a very good choice. Do we need to know how old the tower is? No, that's silly. What about the height of the tower's first story? Well, that really isn't going to matter if we're looking to find the measurement of the base. So realize that if you're trying to draw something to scale, you need all of the dimensions of the actual object. Next, we're going to talk about a scale factor. A scale factor is the ratio comparing two lengths, but in a scale factor, we're using the same unit of measure, the same units of measure. So on the page before we had scales, we were comparing the small drawing to the actual size. Now we're talking about comparing the same units of measure. This is called a scale factor. So when it asks what's the scale factor for 1 inch to 6 feet, well, this is the scale, 1 inch to 6 feet. I'm going to abbreviate scale factor with SF. The scale factor, I need to convert to the same units of measure. So it's going to be easier to convert feet into inches since there's 12 inches in 1 foot. I'll just say 6 times 12, and that'll tell me how many inches are in 6 feet. So the scale factor is 1 to 72. Find the scale factor of 10 centimeters to 5 meters. This is the scale. So what's the scale factor, the SF? We have to convert, and it'll be easier to go from meters to centimeters. Now let's remember good old King Hector. So to go from meters, which is our base unit of measure, over to centimeters, I need to multiply by 100. So I'll say 5 times 100 centimeters in 1 meter. And that converts it over to centimeters, and that's going to be 10 over 500, which simplifies to 1 over 50. So our scale factor here is 1 to 50. We're going to be using scale factor tomorrow when we talk about similar geometrical shapes. So this is a little lead-in to tomorrow's setting up proportions using scale factors. All right, that's all I have for today. You guys have a great day.